Welcome to today's webinar, Introduction to AWS Database Migration Service. Our presenter today is Sergey Sokolenko. Sergey leads product management for AWS commercial database engines, RDS SQL Server and RDS Oracle, and envisioned and launched the AWS Database Migration Service and AWS Schema Conversion Tool. Today with us, we also have a big group of Q&A moderator panel. John Wingford, Senior Technical Program Manager for DBS Migration Service. Ed Murray, Senior Database Engineer for DBS Migration Service. Lynn Ferentine, Business Development Manager for Relational Database, Amazon RDS, and Database Migration Service. And Queasy Edwards, Business Development Manager for Relational Database, Amazon RDS, and Database Migration Service. Also, we have Abdul Singh, Principal Product Manager for Amazon RDS. Our Q&A moderator panel will engage with you and answer your questions throughout today's presentation, where Sergey presents. Sergey, welcome, and I'll pass the floor to you.
Thanks so much. Welcome, everyone. In today's webinar, we'll take a look at the typical migration challenges that our customers talk about when we discuss with them their application and database migration strategies. We'll spend some time taking a look at the AWS Database Migration Service. We'll do a demo of DMS. We'll also take a look at the pricing and other resources that are available to customers. In addition to the Database Migration Service, we'll also review the Schema Conversion Tool, which is a component of the Database Migration Service. We'll do a demo of the Schema Conversion Tool, and we allocated sufficient time at the end of the session for a Q&A panel. These days, a lot of our customers are talking with us about migrating their databases to the AWS cloud. Migrating applications is typically an easier task than migrating the databases which these applications are using. Applications are stateless, and so it's easier to use a lift and shift approach to move them from one environment to another environment. Databases, on the other hand, are stateful, and it takes dedicated effort to establish a replication link from your production source environment to your future target environment, synchronize the data between the two environments, and then do a switchover. So migrating databases to the cloud actually requires a cloud data migration strategy. When you start looking at your cloud data migration strategy, a couple of questions will probably pop into your mind. You'll probably ask yourself, how can I make this migration as easy and transparent to my users as possible? You want to minimize the impact of the migration. You would like your users to continue to be able to use your production environments while the migration is going on. Another question you'll probably ask yourself is, well, now that I migrated a subset of my applications to the cloud, how do I integrate my remaining applications that stayed on premises with the new environment in the cloud, and how do I synchronize data between the two? Furthermore, once you start moving more and more workloads to the cloud, you'll be asking similar synchronization questions related to your data assets that are already in the cloud. How do I make sure that these databases are in sync? How do I exchange the data between my databases in the cloud? Lastly, a lot of our customers are also asking us for help with migrating of commercial databases, which typically carry a significant licensing burden, and asking us if we have any tools to help them with switching from, let's say, Oracle or SQL Server to open source engines such as MySQL and Postgres. Historically, migration meant significant cost and time investments. Customers had to use commercial data migration and replication software, which was not easy to set up and manage. And customers also had to deal with a lot of legacy code written in languages such as PL SQL or T-SQL, which didn't have direct equivalents in the open source world. Lastly, one of the big issues was also the downtime related to application migration. You have to switch off your production application during the migration and cease access to it for your users. To address all of these issues, we have recently launched the AWS Database Migration Service, which is currently in preview. The Database Migration Service makes it really easy to start your first migration. You can actually launch one in less than 10 minutes. Furthermore, you can keep your applications running when you're doing the migration. You set up a replication link between your source and target database. We do a bulk load, initial bulk load of the database. We start applying and collecting changes on the source. We apply them to the target. Meanwhile, your applications can still use your source on-premises environment. After you migrated your database, you can use the Database Migration Service for other things, for example, for ongoing replication. You can replicate within data sources, you can replicate data sources within the AWS environment, for example, between databases on RDS or databases on EC2. But you can also use the Database Migration Service for moving data in and out of the AWS cloud. For example, if you wanted to keep a copy of your database on premises, you can use the Database Migration Service for that purpose as well. Lastly, in addition to supporting homogeneous migrations, meaning moving data from engine A to engine A just in a different environment, we also support heterogeneous migrations. For example, you can move data from Oracle to Aurora, or you can use the Database Migration Service to move data from SQL Server to Postgres. Let's take a quick look at how the Database Migration Service makes it easy to set up a migration task. I will start my demo in the AWS Management Console, which is the typical entry point for customers when they use the AWS applications. I will navigate to the Database Migration Service pod, and the console will will set me up with the DMS dashboard. The dashboard contains several useful links, which we'll review later on in this presentation. For example, it contains links to user guides and will allow you to download the Schema Conversion Tool. But for now, I will start with the creation of the replication instance. You can think of replication instances as your central hub that connects source databases with target databases. It allows you to set up transformations, basic transformations of the data between the source and the target. So let's create a new replication instance. I will give the instance a new name. I'll just type REP and then my initials and give it a new sequential number. I'll enter some descriptive text that identifies my replication instance. I'll choose the instance class. Instance classes are basically a way for you to define how big and how performant you want the replication instance to be. In this particular demo, I'll choose the C4 large instance type. It allows me to, this instance class is optimized for migrating large databases with minimal latency. I will also pick a VPC. I want this replication instance to reside. VPCs can be thought of as subnets or subnetworks, which you can protect with permissions and secure your environment that way. I would like my replication instance to run in one of my VPCs where my target database resides. Because I would like this replication instance to be able to access outside databases as well. For example, when I move data from on-premises databases to the cloud, I will check the publicly accessible checkbox. This checkbox will indicate or will tell the service to make outside resources available to this replication instance. That's it. I will click on the Create Instance button, and the creation process will initiate and complete within a couple of minutes. I don't want necessarily to wait until the completion of this process. It does take a few minutes to complete, so I'll just continue with the second step of this three-step process. So after I created my replication instance, I will create endpoints both for the source database and the target database. I need to tell the replication instance which database I would like to migrate data from and which database I would like to migrate data to. So the source database will be a Oracle database. My target database will be a Aurora database. So for the source, I'll enter the name of my Oracle DB. I have a Oracle database called SSO36 Production Oracle, and I'll put the SRC label in the name just to indicate what kind of a resource it is. I'll pick the engine, the Oracle engine as my endpoint engine, and I'll also copy a connection string. These connection strings tend to be quite lengthy, so I saved a few of them in a notepad. I'll copy this information in the server address field. I'll then enter the listener port for my Oracle instance. I'll also confirm the username and the password, and I will enter the service ID for my Oracle database. As the last step, I will verify connectivity to my Oracle database. It's always a good idea to actually validate you can connect to your endpoint before you save this info. So I'll run a connectivity test. The connection testing will be done on the actual replication instance, which will be used for moving data. It will typically take 5 to 10 seconds to connect to my database. In addition to connecting to the database, I will also retrieve some metadata related to the source DB. The test completed successfully, so I'll save my endpoint. I will now continue with the creation of the endpoint information for my target. Just as a reminder, my target is I would like to migrate data into a Aurora cluster, and I have one empty Aurora cluster available for this demo. I'll just enter the connectivity info for it. I'll pick Aurora as my engine, and I will copy the connectivity connection string for my Aurora cluster, the port number, and the username. Similarly to the source, I will also test the connection for my target. During this connection test, I instructed the service to refresh the schema information. So the service will pull all the database schemas available in my target database into the service and will save it for further use. The test completed successfully, so I'll save this endpoint as well. The last step of this process, of this three-step process, is creating a migration task. Think of migration tasks as something that combines the source database, the target database, and some rules that define how you want the data to be processed between the source and the target. I'll give the task a descriptive name, migrate Oracle to Aurora. I'll pick my replication instance. I'll pick one of the source endpoints and the target endpoint, and I'll also pick the second migration type here. I'll basically do a bulk load. We call it also migrating existing data. And after the bulk load, I will choose to apply changes that are happening on my source. I'll choose them to be applied to the target. We also call this process, or this step of the process, ongoing replication. The console will show me a message that tells me that since my source engine is a Oracle database, I need to enable supplemental logging. I have done this before the demo, so I don't have to do it now. I'll keep the start task on create checkbox checked. What this will do is after I finish the creation of the task, the database migration service will automatically initiate the bulk load and then continue with the ongoing replication. And lastly, I will confirm the mapping method for tables and schemas for this particular migration task. I have several schemas deployed to my source database. One schema is called Chinook. Chinook is a sales-oriented application for selling music records online. It has about a dozen tables and several code objects such as store procedures and triggers, etc. I have also other schemas in the database as well, but for this demo I'll pick just one schema to migrate. That's it. After clicking the Create Task button, the process will initiate and I will be able to monitor the progress of the migration as it proceeds in the complete percentage column. Let's go back to my main presentation and just review the architectural diagram of what is going on right now on the screen. So here's the diagram that represents a typical migration workflow when a customer wants to move on-premises data to the AWS environment. On the left-hand side, the box represents a network on customer premises and a database in that network. On the right-hand side, I've put a new database that I've just created, and this database is in the AWS environment. It's actually a VPC, a virtual private cloud, in which this database is deployed to. One recommendation we make to customers is to establish a virtual private network to connect the on-premises environment and the target AWS environment. This VPN can be either a direct connect network connection, or you can use another VPN technology. In my simple architectural diagram, I have a couple of applications accessing my existing on-premises customer database. These applications users can be either executables or they can be application users, humans who run queries against the on-premises database. So as you've seen in the demo, the first thing I did to move data from my source database to my target database is creating a replication instance. I then connected the replication instance to the source and target databases. And I selected a schema that I wanted to migrate. And I then let the database migration service populate the target by creating tables in the target that represent data and information in the source, by starting the bulk load process, and by continuing with the ongoing replication process. When these processes will populate the target database, and I see that my target DB reached the same state as my source database, that would be a good time for me to switch my applications from the old environment to the new environment. I also wanted to spend a few minutes discussing in more detail how the database migration service works. As I've mentioned before, the database migration process is divided into two phases. The first phase is the bulk load. It's basically when we take a snapshot of your existing source database and move that entire snapshot to the target database. The second phase is when we capture changes on your source database and apply them to the target. We also call the second phase the CDC capture change data capture phase, or ongoing replication phase. This particular slide explains or gives a bit more detail on the bulk load phase, on the first phase. All my tables in my source database are transferred to the target database individually. We first create tables in the target database. We then set up some metadata that is required for the migration process. We start populating the target tables with the data from the source. Each individual process or each individual table is being handled by one process. There is a way, though, to parallelize the bulk load process and use multiple processes or multiple threads to load multiple tables in parallel. The replication or the bulk load process can be stopped, can be paused. It can also be resumed and restarted. And when we restart, we will restart from the place exactly where we stopped with the table load when you clicked on the pause button. We will reload the tables in progress as well as all the tables which were not yet loaded. The second phase of the database migration process is change data capture and apply. It starts when the bulk load process ends and we are ready to apply transactions that transpired during the bulk load process and after the bulk load process. If you have transactions which update multiple tables, for example, there's an update statement executed against your source database, and this update statement touches two tables, T1 and T2, for example, in this particular example. These changes will be applied in one transaction on the target as well. We will only start applying changes after we finish the bulk load. The change data capture process is a no-touch process, so we don't require you to deploy any agents on your database source. This minimizes the impact to your production environment. And we use the recovery logs of each individual engine and the native change data capture APIs of each engine to access this recovery log and extract the changes that transpired on your source database. For example, for Oracle, we use supplemental logging. For MySQL, we use row-level bin logging. For SQL Server, we ask you to run your SQL Server database in the bulk log or full recovery mode. And for Postgres, we use the write-ahead logs. You can use the Database Migration Service to move data from a single source to multiple targets. You can also use the service to integrate data from multiple sources into a single target. You don't necessarily have to move everything that is in your source database. For example, if you have 5 tables but you only want to move 3, you can certainly do that with the Database Migration Service. You can even move a subset of a 4th table. And if you want to skip a 5th table entirely, that's possible as well. The Database Migration Service supports multiple modes of data movement. You can use the Database Migration Service for homogeneous migrations. For example, if you have an Oracle database on premises and you would like to move that database to RDS Oracle, you can do that with the Database Migration Service. You can also use the Database Migration Service for heterogeneous migrations, changing database engines in the process. You can start with a SQL Server database on premises and move to a RDS MySQL database. Or you can start with a Oracle database and move the data into a Amazon Aurora database. After you migrated your database, you can use the Database Migration Service for ongoing replication. And there is a multitude of use cases for ongoing replication. I'll just mention a couple. For example, you can replicate your data from on-premises databases to AWS. If you just want to wet your feet and would like to keep a read copy of your production data in AWS while you're continuing using your on-premises database for production purposes, you can use the Database Migration Service for this purpose. You can also use the DMS service for for populating data warehouses, specifically Amazon Redshift. So we have a connector for Amazon Redshift, and you can move your Oracle and SQL Server and MySQL and Postgres data from your OLTP databases into a data warehouse based on Amazon Redshift. Lastly, you can use the service for data integration purposes. For example, if you have third-party software such as PeopleSoft or JD Edwards or any other third-party software, and you would like to capture some of the transactional data and put it into a reporting database, the Database Migration Service will certainly support that. How about pricing? We price the Database Migration Service such that the database migrations are really cost-effective to do. We offer two instance families for the Database Migration Service. For those of you who are not familiar with our terminology, T2 instance family is typically a development class or a type of an instance that is ideal for periodic or spiky workloads. For example, if you would like to do a data sync or data migration a couple of hours a day, every day, a T2 instance would be ideal for such a workload. The C4 instance family is optimized for high performance, high productivity migration tasks. If you have a large database or if you would like to minimize the time required for data migrations, please use the C4 instance family. Pricing for the T2 micro instance class starts at less than 2 cents an hour, and pricing for a C4 large, the smallest C4 that we have, starts at about 15 cents an hour. In this cost, we are including about 50 to 100 gigabytes of storage, which can be then used for deploying the binaries of the service as well as for log files and cache. If you would like to get more storage, you can pay the regular storage rates and just tell us that you would like to have more storage for example, logs. Data transfer is free when you transfer data inbound. When you transfer data within availability zones, Amazon availability zones, that data transfer is free as well. If you move data across availability zones, that data transfer is charged starting at a cent per gigabyte. And lastly, we're currently in preview, and so all usage of the Database Migration Service is free right now. Once we launch the service in GA, we will start charging according to the prices I just talked about. Let's review the resources available to customers. And a great entry point for these resources is the DMS dashboard. Navigate to and find the additional info panel on the dashboard. That panel contains many useful links. Let's review them. If you just want to learn about the service, use the Getting Started guide. We also have deeper technical documentation available, so you can review that after you started with the Getting Started guide. If you would like to review features and benefits of the Database Migration Service, we have a link that points you to a web page with a short description of all the benefits. Pricing information is linked from the dashboard as well. If you have questions and need support, you can ask and post your questions to the support forum. We have several colleagues from the team members who regularly answer questions on the support forum. We also provide a Java-based SDK, and you can use this Java-based API for automating a lot of the creation and data management tasks. Lastly, we offer, in addition to the Java SDK, we also offer a command line interface. You can use the CLI for example, starting and stopping replication tasks. So far, we've been talking about the cloud data migration strategy and how to move data from one environment to another. For the customers who ask us about help with migrating off commercial databases, we have recently launched the AWS Schema Conversion Tool. This tool is automating a lot of conversion tasks for your database schema and the code that is embedded in your database. When you're migrating from commercial databases such as Oracle or SQL Server to the open source databases such as MySQL, Aurora, or MariaDB, or Postgres. As part of the Schema Conversion Tool, we are offering a database migration assessment, which is basically a report which will show you what the best target engine is for your specific source database. In addition to the assessment report, we also offer you a code browser. And this code browser is an interactive utility, interactive tool. It highlights all the places where we were not able to automatically convert the code in your source database, and where manual edits are still required. Let's review what the Schema Conversion Tool does and doesn't do. The Schema Conversion Tool is able to convert most of the database storage objects, things like tables and indices and schemas. The Schema Conversion Tool is also able to convert a lot of the database code that is incorporated in store procedures, in packages, functions, and triggers. But not all code can be converted. For example, MySQL compatible engines do not have native support for concepts such as sequences or user-defined types. Postgres, for example, does have support for such concepts. To help customers who would like to move to various database targets, we developed a code browser and a recommendation engine which shows you exactly the locations where manual edits are required, and where we provide architectural and design guidelines, which we call recommended actions, to tell you exactly what is required in terms of manual development work to complete the conversion project. Let's see this in a demo. I will start here with a Oracle database that I already used for my DMS demo. This database is called SSO36P Aura, and it's an Enterprise Edition database that has multiple schemas, including the Chinook schema. The Chinook schema has about 11 tables with information related to invoices, customers, and various music records that I'm trying to sell online. It also has a couple of views, several store procedures, several functions, and a couple of sequences. In my migration project, I want to migrate and convert this database, the schema of this Oracle database, into either Aurora target or a Postgres target. So I'll go to the Schema Conversion Tool and initiate a new migration project. In the Schema Conversion Tool, I will choose to run the new project wizard, and I'll confirm that my source database is an Oracle database. I've done this before, so the Schema Conversion Tool has saved the connectivity information to the databases I used in the past. I'll just confirm the password for this database for security reasons. It's not stored in the project. I'll test the connection and click Next. At this stage, the Schema Conversion Tool will populate some basic metadata, specifically the the schemas that are available in my source database. I'll choose the Chinook schema. The schema conversion tool will apply hundreds of conversion rules and will evaluate the my source database against these rules to come up with a couple of simple statistics. It will create the so-called database migration assessment report, and as part of this report I will be able to see conversion statistics for my database storage objects such as tables and indices, as well as for database code. And I'll see these statistics both for the MySQL compatible engines as well as for Postgres compatible engines. For example, for my source database, I see that the schema conversion tool is able to convert all my tables and all my constraints, but sequences will not be able to automatically convert it to a MySQL database, and so I'll have to apply some manual work to move my sequences. On the other hand, when I compare this to the Postgres migration, I see that the same number of storage objects are successfully migrated to Postgres, and the two sequences that were not supported in the MySQL's case will be actually converted automatically into Postgres. When I look at the database code objects, things like views and procedures and functions, my MySQL section indicates that I'll be able to convert the majority of the database code objects. So 20% of the 5 stored procedures I have will be automatically converted, and for the rest, about 4 out of 5, I will have to apply some basic, some simple actions to complete the conversion work. When I compare this to the Postgres migration, I see, for example, that the tool is able to convert more automatically, so 4 out of 5 will be converted automatically, but there is one stored procedure which will require a significant rewrite. So based on this information, I think I'll go with the Amazon Aurora as my migration target, just because I get a little bit more automatic conversion out of the stall. On the next screen, I'll choose Amazon Aurora as my target database engine, and again the tool will save and present me the connectivity information I've used in the past. I'll just confirm this information and enter the password. And I'll finish the visit. So at this stage, the schema conversion tool pulls the metadata information from my source and my target. It pulls all the schemas from both source and target, and it runs the conversion one more time, just focusing on my selected conversion pair, which is Oracle to Aurora. Once the process stops, once the metadata retrieval stops, I will be able to either convert the schema and apply it to my target database, or I'll be able to run another report. Let me do the former. Let me actually run the conversion functionality and convert the schema to my target database. It runs very quickly. At this point, I have several options. I can review the code that was generated by the schema converter. For example, I can confirm that I have all my 11 tables in the target that I used to have in the source, that I have my 2 views and my 5 stored procedures and my 4 functions. And after I confirm that the code that the schema conversion tool was able to successfully map each object, I have 2 options available to me now. I can either save the schema, the new schema, as a SQL script, or I can apply the schema directly to my target database. Before I apply the schema to the target database, let me just quickly show you the empty database I created for this demo. I switched to the MySQL Workbench, which is my preferred tool to work with any MySQL compatible database, and here it goes. I have a couple of system schemas in my database. They are created by default when I create a RDS MySQL or a Amazon Aurora instance. I'm going to apply the newly generated schema to my database. It's complete. And then switch back to MySQL Workbench and refresh the browser here. And now I can see my Chinook schema and an additional schema which was generated, which gets generated for any Oracle database that we migrate to a MySQL compatible database. As you probably know, MySQL has somewhat less functionality available for its store procedures and functions. So my team has created an extension package that complements the missing functionality in MySQL and provides some Oracle functions that are not by default available in MySQL. Let's review the contents of the Chinook schema. You can see that I have my 11 tables generated. I have my 2 views that we are in the source and are now in the target, and my 5 store procedures and my functions as well. Voila, that was an easy way to migrate an Oracle schema, database schema to a Aurora schema. Let's continue with some of the other resources that we make available as part of the schema conversion tool. Ryan, would you mind switching me back? Thank you. What about pricing? Pricing is really easy for the schema conversion tool. There is no license fee associated with the schema conversion tool. The schema conversion tool is a desktop tool, so you need to download this to your desktop. And we make the tool available for 4 different OSs. It's available for Windows and Linux, 2 flavors of Linux, as well as for Mac OS. In order to use the schema conversion tool, you do need to be a Amazon customer with an account in good standing. You can use the schema conversion tool to migrate schemas, database schemas, to any database deployed to AWS, for example, on RDS or Redshift or EC2. If you would like to use the schema conversion tool to migrate to a different environment, please get in touch with us for special pricing. We also make available a bunch of other resources to customers. Let's quickly review what we offer. If you would like to take a look at the user guide for the schema conversion tool, you could navigate to the DMS dashboard I've showed you before and find another panel called the AWS Schema Conversion Tool. In that panel, you'll see a download button. This download button will actually lead you to the technical documentation area. I also mentioned the URL on the slide. In this technical documentation area, you will find the user docs as well as links to download the tool. You'll find the download links and installation files for Windows, for macOS, for Ubuntu, and for Fedora. If you have questions you would like to ask us, our team is responding to questions on support forums. The support forum we are operating, the ID is 208. You can also Google us and just look for support forums for schema conversion tool, and you'll find the link to it. To help customers with their database migration projects, we have partnered with several great solutions integrators. And these folks specialize, have specializations in different areas, and are certainly able to support a multitude of use cases our customers can throw at them. So we partnered with Second Watch, with Apps Associates, with Cloud Nexa, DataPipe, and UST Global, and LogicWorks, and Pythian, and Slalom. If you would like to get some help in your database migration project, please navigate to the RDS Partners page and look at the profiles of these partners under the database migration section of that page. To summarize, if you would like to start using the database migration service, the first thing I would recommend you doing is to go to the AWS Management Console and finding the DMS shortcut, the shortcut to the DMS page of the Management Console. Once you clicked on the shortcut, you'll be presented with a dashboard, and on that dashboard is a link to a wizard which simplifies many of the steps for creating a migration task. You can either use this wizard or you can use the steps I showed you in my demo, where I created a replication instance first and then set up endpoints and started a migration task. Either of these options will work. And lastly, if you would like to evaluate a conversion path from a commercial database to an open source database, download the AWS Schema Conversion Tool. The download links to the Schema Conversion Tool are available through the DMS dashboard.